Hi, we're Team One More Thing. My name is Saketh.
My name is Delvis Taveras.
And I'm Niharika. Signh.
We're planning on working on the Super Nintendo Entertainment System. We want to use this particular project. We want to work on this particular project because we've spent a lot of our time playing on it, and we also noticed that this project has been something that has never been done before. A team has attempted this a couple of years ago, but they did not seem to have succeeded completely. As far as our project description goes, we want to have a fully functioning SNES. So this would mean we want to be able to use the original controllers to play the game, and we want to be able to use the game cartridges to just plug it in and go. We have plenty of external support because the SNES is a fairly old system, and there are a lot of emulators and online documentation for the SNES. We've also reached out to the Western Design Center, who provided the original CPU core to Nintendo, and they agreed to give us a Verilog description of the CPU. We also have the previous team's project report to fall back on, so that we can note their pitfalls and also the ways they overcome some of their obstacles. We plan on using the Vertex 5 with OpenSpark as our design platform, and we want to use Verilog to describe our hardware. We plan on using Bitbucket as our code repository and Box for documentation. Like I said, we want a completely functioning SNES, so this would mean fully functioning video and sound and CPU modules. We want to be able to use the controller and the cartridges. We want to be able to support multiple games as well, and at least 2 simultaneous players.
Okay, so this is our pitfalls to avoid and plan for success. So we realized that this is a difficult project as the previous team wasn't able to complete it. And although it motivates us, we also want to figure out what it is that they did wrong. And one of the things that we've seen is that we need to start early, do enough research, not too much, but just enough. And on that note, we've already have as much research as the previous group and some more. And another thing, don't leave testing and integration to the end. And the previous team, they began with the SPC 700 chip and the DSP, which is basically they started implementing sound before implementing the pixel processing unit and using the CPU, which they didn't get early enough to start on that, which we're hoping to get early enough that we can start with that. And we want to leave enough time for testing and debugging, just because making a clone of a system that we don't perfectly know is always going to come with some bugs, and at the end we want to make it as clean and as best we can. So we want to leave enough time for that. And this here is a high-level system schematic of the whole SNES. As you can see, it has every component. The red is the pixel processing unit. The blue is all the sound chips, and the orange or yellow is the CPU. And basically we also have other schematics more specific to the chips, although we don't have all of them. And basically we're gonna try to implement this system as best we can with all the data buses and the clock, and hopefully that's what we're going for.
Alright, so just splitting apart these components in more detail. The first part is the CPU, and this is a custom chip that Nintendo had built for them, but it's based on a chip that the Western Design Center is willing to give us the Verilog description for. So we'll be able to use that and then just modify it a little bit to make sure it works exactly like the custom Nintendo chip. The CPU has software and hardware interfaces since it's in the middle of everything. For the software side, it handles the controller inputs, it handles the interrupts from the other chips on the board, it has direct memory access to transfer data between the buses, and it handles multiplication and division for floating point and fixed point integers. And for the hardware interfaces, it reads the data from the cartridges and the controllers. And a lot of the cartridges have custom features that we'll have to account for when we design this. The next part is the sound. There are two chips that handle the sound. There's the CPU that tells the DSP what to do, and they both share a common memory that's 64 kilobytes. So the DSP performs a lot of custom functions that just create sounds exactly like the CPU tells it to, and the CPU handles giving the controls. And finally, there's the video. The video is 2 pixel processing units, and they both have memory that most of it is used for screen maps, but there's also memory for other parts on screen. And both these PPUs work together in similar ways, but one of them handles backgrounds and maps, and the other one handles the sprites. And
the last thing, or one more thing, is we do have a backup plan, although we do not want to do this, but we should have one, and we do have one. So the first thing we'll do is cut down on the number of games that we implement, because the system itself has certain components that are required for certain games. So we'll just have to diminish that. And worst case scenario, we will attempt to port an emulation of the SNES to the OpenSpark CPU. But like I said, this is worst case scenario, and our plan is to start early and hopefully get the system working as soon as possible. But this is basically our backup plan. And thank you.
Yep. Thank you for listening to us. We hope you enjoy our system.